Welcome, everyone. Today we're going to level up. We're moving past some of the simpler tools you might be used to and diving into something really powerful for dynamic analysis. It's a technique called integration by parts. Now, this is absolutely essential for solving the kinds of constantly changing problems you're actually going to face out there in the business world. This isn't just about finding an answer to a static equation. It's about learning how to model reality.
All right, let's just jump right in with a scenario. I want you to imagine you're the CFO of a super fast-growing tech startup. It's your first year, and things are going great. You're not just adding new customers every month, you're also getting better at upselling them, which means the average revenue you're pulling in from each customer is also going up. So, how in the world do you calculate your total revenue for that first year? You can't just take the number of customers at the end of the year and multiply it by the revenue per customer at the end of the year, right? That would completely ignore all the money you made back in month 2 or month 6 when both of those numbers were a lot lower. You're dealing with a dynamic system here, and simple multiplication, well, it's just not going to work.
And this isn't just some abstract math problem we cook up for an exam. This is a legitimate, high-stakes business challenge. Your ability to accurately pin down this accumulated revenue, it affects everything. It's going to be the number you take to your next round of funding. It determines your hiring budget, your marketing spend, everything. Getting this number right is absolutely critical. And to do that, we need a much more sophisticated tool.
So the heart of the issue is that we're dealing with continuous change. When the functions that represent your growth, whether it's customers or revenue, aren't just flat, straight lines, you can't rely on simple arithmetic. What we really need is a way to sum up an infinite number of tiny little revenue snapshots over that entire year. And what is that process of continuous summation? Well, that's integration. That's where calculus comes in. It gives us the language and the tools to model these dynamic systems with real precision.
So the problem is clear, and we know that integration is the path forward. But our total revenue in any given moment is a product of two changing functions, our user growth function and a revenue per user function. And to solve the integral of a product like this, we need to bring out a specific, elegant, and frankly essential technique from our calculus toolbox, integration by parts.
Now, before you look at that formula on the right and think, oh great, another thing to memorize, let's just pause. I want to connect this to something you already know inside and out, the product rule for differentiation. Remember that? The derivative of u times v is u dv plus v du. Well, integration by parts is literally just the product rule in reverse. I mean it. If you take that product rule formula, integrate every single term, and just do a little bit of algebraic shuffling, you end up with the exact formula for integration by parts. It's not some new random rule pulled out of thin air. It's a logical extension of what you've already mastered.
And here's the formal definition. I want you to really focus on that last part, transforming a complex integral into a simpler one. That right there is the whole point. That is the entire strategic purpose of this technique. We aren't just solving something, we are intelligently restructuring a problem that looks hard, maybe even impossible, into one that's suddenly manageable.
Okay, let's really look at what's happening in the formula, because this is where the genius lies. On the left side, you've got our original problem, the integral of u dv. It's a product, it's difficult. Now, look at what the formula gives us on the right. It splits our problem into two distinct pieces. The first part, uv, hey, that's a finished product. There's no integral sign there. That part's done. The second part, the integral of v du, is a brand new integral. And here's the magic. If we've chosen our parts correctly, this new integral is significantly easier to solve than the one we started with. We're essentially trading a hard problem for one solved piece and one easy problem. It's a brilliant strategy.
All right, enough theory. Let's get our hands dirty. We're going to take that startup revenue challenge we talked about and solve it, step by step, exactly how you would do it in a real-world business analysis meeting. Okay, let's walk through this process. Steps 1 and 2 are all about setting the stage. We define our functions. Let's say our user growth, u of t, is an exponential function, and our revenue per user, p of t, is a simpler linear function. We set up our integral as the product of those two. And now, we get to the most important part of the whole process. Step 3. The strategic choice of u and dv. Remember, whatever we pick for u is what we're going to differentiate, and dv is what we'll integrate. The key, the absolute key, is to choose a u that gets simpler when you differentiate it. Now, a really helpful little mnemonic here is LIAT. It stands for logarithmic, inverse trig, algebraic, trig, and exponential. You generally want to pick whatever function type appears earliest on that list to be your u. So in our startup example, we have an algebraic function, our linear revenue, and an exponential one, our user growth. A comes before E in LIAT, so we're going to choose that revenue function as our u. That single choice is what will make our new integral, the integral of v du, so much easier to solve. Once that critical decision is made, steps 4 and 5 are really just execution. We calculate du and v, plug everything into the formula, and solve our new, much friendlier integral. And this quote just says it all, doesn't it? This technique is so much less about rote memorization of a formula and so much more about strategic thinking. The real heavy lifting, the real brain power, happens right there in step 3. Getting that choice right is what separates a frustrating hour of going in circles from an elegant, beautiful solution. You have to think like a strategist, not just a calculator. Now, as with any powerful tool, there are a few common places where people can get tripped up. So let's just address these potential pitfalls right now, head on, because understanding them is how you build confidence and make sure you can apply this technique flawlessly, whether it's on an exam or in your future boardroom. So let's break it down. Where do students typically go wrong when they're first learning this? And more importantly, what are the simple habits you can build right now to make sure you avoid these common errors completely? Okay, the first and by far the biggest one is making a poor choice for you. We talked about liate, but here's a gut check for you. If you make your choice, calculate your new integral, and that integral v du looks even scarier and more complicated than the one you started with, that's a giant red flag. You've probably gone the wrong way. Don't be afraid to just stop, go back, and swap your u and dv. The second mistake is simple algebra, especially with that minus sign in the formula. A tiny detail, but it can wreck your whole answer. Here's the pro tip. Always wrap that second term in parentheses. uv minus integral v du. It's a simple habit that will save you from so many sign errors. And finally, a really common slip-up is just forgetting to integrate dv to find v. You get caught up in the big picture and forget that v itself is the result of a calculation. Just keep your work organized and remember you have to integrate dv before you can use v in the rest of the formula. So, we have the tool, we know how to use it, we know what mistakes to avoid, but let's zoom out for a second. What's the real payoff here? Why have we spent all this time mastering what is, admittedly, a pretty complex mathematical technique? Because it leads to this, a concrete, defensible number. After we run our startup's functions through the integration by parts formula, we get a precise figure for our total revenue in that first year, $1,250,000. This is the answer to our dynamic problem. And let's be crystal clear. This is not just some number you put on a spreadsheet. For a CFO, for a business leader, this number is ammunition. It is the verifiable proof of your company's growth that you take to investors. It's the rock-solid foundation for your next year's budget. It's a cornerstone of your company's valuation. Precision here isn't an academic exercise. It is a critical business imperative. And the power of this method goes way beyond our startup example. In finance, you're going to use this to calculate the present value of an income stream that changes over time. In marketing, it's crucial for accurately figuring out customer lifetime value when things like churn rates aren't static. In economics, it lets you precisely model concepts like total consumer surplus. This one single technique unlocks a more sophisticated, more accurate level of analysis across every single discipline of business. So here's the real takeaway. We haven't just learned how to solve a particular type of integral. What we've really learned is how to model and quantify dynamic systems. So I want to leave you with this question to think about. Now that you have this tool in your toolkit, what other complex real-world business challenges, from supply chain logistics to resource depletion to market penetration, could you now analyze and solve? That's where the real learning and the real power begins.